Hello, myself Dr. Rakesh Kumar, Associate Professor, Department of Mechanical Engineering, Shahid Bhagat Singh State Technical Campus, Firozpur. I am going to take a lecture on CAD/CAM and FMS. CAD/CAM is computer aided design and computer aided manufacturing, and FMS is flexible manufacturing system. CAD/CAM is computer aided design and manufacturing. It is the technology concerned with the use of computers to perform design and manufacturing functions. CAD can be defined as the use of computer systems to perform certain functions in the design process. So, these functions are creation, modification, analysis or optimization of the design. Therefore, we can also say that CAD is the use of computers in creation, modification, analysis or optimization of the designs. Similarly, CAM is the use of computers to perform certain functions in the manufacturing process, and similarly it can be said that CAM is the use of computer systems to plan, manage and control the operations of manufacturing plant through either direct or indirect computer interface with the plant's production processes. From the definition of CAM, we can say the application of CAM falls in two broad categories. In category 1, computer monitoring, the application of CAM is for computer monitoring and control. In this application of CAM, the computers are in direct connection to the processes. The computers directly control the processes in this application of the computers. So, as shown in the as depicted in the diagram, further there are two categories. In the first category, the process data is received from the process by the computer and the only function that is performed is the monitoring function. Whereas, in the second diagram it has been shown that you can see here the processing data is being received from the process by the computer, and on the basis of the process data, the control signals are being fed to the process, and hence the control function is also being performed in this particular computer monitoring and control function. The second computer applications for CAM is manufacturing support applications. These are the indirect applications, or we also say that these are the offline, this is the offline use of computers. So, in the offline use of computer, we make use of the computer for different supporting activities which are required for the manufacturing. For example, making of the manufacturing plans, for example, drawing of the manufacturing schedules, forecasting of the production quantities, instructions to the people on the shop floor, or anything which makes organization more efficient. So, it has been shown in the diagram by the dotted lines, the process data is obtained offline from the manufacturing operations and it is processed, and control signals are also shown dotted. It shows that the results of the computers are used for manufacturing operations offline. So, some examples of manufacturing support applications are numerically controlled part programming methods, CAPP, computer aided process planning, computer generated work standards, production scheduling, MRP, material requirement planning, shop floor control, etc. So, before moving further, in order to establish the scope and definition of CAD/CAM in an engineering environment and to identify existing and future related tools, a study of a typical product cycle is necessary. In the following figure, we have shown a flow chart which shows the product cycle for any product, and it has been related to the CAD/CAM. So, this is a typical product cycle. It starts from the feedback of design needs which we obtain from the market, from the consumer. So, on the basis of these design needs, the definition is given to the expected or the future product, and its specifications are prepared and the requirements which are needed for it are enlisted, and then collecting then the data which is required for the design, may be technical or any other kind of data is collected, and the feasibility study of the product is also conducted, the feasibility study. It could be all of environmental feasibility, technical feasibility, manufacturing feasibility, financial feasibility, or marketing feasibility, or either it is going to be all of these or some of these, depending upon the product. Then design is conceptualized and its modeling and simulations are conducted, and the and we make the initial design, and initial design is analyzed, optimized and evaluated, and the cycle of analysis, optimization and evaluation is repeated until we get the final design, and the final accepted design is then documented and communicated to the manufacturing people. So, once the design has been communicated to the manufacturing people, they have to begin the process planning for the manufacturing of the product. So, process planning is nothing but a listing of operations that is required for the manufacturing of the product, and it also includes routing which associates each process of manufacturing to the various machines available in the plant. And after the process planning, these are the activities which are required for actual manufacturing of the plant. These activities are production planning, design and procurement of the new tools if required for the for realizing the process plan accepted, and ordering the raw materials as per the requirement generated by the process plan, and the quantity that has to be manufactured, and NC, and we require NC, CNC, DNC machines and facilities for their programming. So, once all these things are integrated, collected, the production may be started, and after production we have to control the quality of the products, and the quality products accepted which pass through the quality control section are packaged, shipped and reaches the markets. Again markets gives us newer feedbacks, and the whole product cycle may be repeated to give birth to a new product. So, this way the whole product cycle completes from the design to the markets and from market to the design. So, now we can see in this diagram that first we have seen some of the steps with dotted within a dotted box of red dots, and some of the steps has been shown in the dotted box of green box. So, and one more distinction is there is one box which is encircling 1, 2, 3, 4, 5, 6, 7, 8, 9 steps of this procedure, and these first 9 steps of the procedure corresponds to the design process. The out of these 9, the 5 first steps are the synthesis steps, and the remaining 4 steps are the analysis steps of the design process. The lower box enlists the remaining steps in the product cycle, and this corresponds to the manufacturing process. The design process, when it is assisted by the computers, is called the CAD process, and the manufacturing process, when it is assisted by the computers, is called the CAM process. So, as I said, here I am going to summarize what we learnt in the last diagram. The product begins with a need which is identified based on customers and markets demands. The product goes through 2 main processes, from the idea conceptualization to the finished product, the design process and the manufacturing process. The main sub processes that constitute the design process are synthesis and analysis. So, once again we are going to see it again in the light of this conclusion. Implementation of a typical CAD process on a CAD CAM system. So, these are the steps which are required for the implementation of a typical CAD process on a CAD CAM system. Delineation of geometrical model, and after the geometrical model is delineated, the definition is translated and a geometrical model is prepared. And through interface algorithms through interface algorithms, design and analysis algorithms, drafting and detailing is prepared, and the finally accepted design is documented, and the output of the design process is becomes the input to the CAM process. So, this is the whole, and whenever there are design changes after design and analysis algorithm, the process is sent back to the delineation of the geometrical model. So, these are here we have listed various CAD tools which are required to support the design process. So, in the first column we are showing the different phases of the design, and in the second we are showing the CAD tools which are required during that design phase. So, one design phase is design conceptualization, and the CAD tools required are geometrical modeling techniques, graphics aids, manipulations and visualization. Second design phase is design modeling and simulation. It requires all the CAD tools which are required in the design conceptualization. In addition to that, it requires animation, assemblies, special modeling packages. Third stage of design is design analysis. In this we require analysis packages, customized programs and packages. Next stage of design phase is design optimization. So, for this the tools required are customized applications, structural optimization. For example, design evaluation, for this we require dimensioning, tolerancing, BOM, NC, and the last design phase is design communication and documentation. For this we required CAD tools for drafting and detailing. So, all of these CAD tools which are required to address to the needs of different phases of the design are can also be purchased separately or as bundles or packages. So, depending upon your requirement, whether you are dealing with all the phases of the design process or you are dealing with only certain phases of the design phase, we can make purchases of the required CAD tools, because the whole package is going to be a very costly affair. So, one need to purchase only which is required. So, normally in our diploma level courses and in first year of the degree level courses, we purchase CAD tools which are related to drafting and detailing and corresponding to the design communication and documentation, and geometrical modeling packages which corresponds to the design conceptualization stage. Now, we are going to see, once design is over, the output of the design, as I said, is used as input for the CAM system. So, how implementation of a typical CAM process on a CAD/CAM system is achieved. So, once the output of the CAD is generated as a geometrical model, interface algorithms are used to interpret that geometrical model into a form which is understandable from the point of view of the manufacturing. So, we call this as interface algorithms. So, once the interface algorithms are able to interpret the geometry, the process planning is prepared. Process planning, as I mentioned earlier, is the making of list of processes which are required for manufacturing the intended product. And once different machines are assigned different processes for manufacturing of a product, then each machine has to be programmed. If the NC or CNC or DNC machines, then each machine has to be programmed for doing the part of the process that it has to do for manufacturing of that plant. So, this CAM process is called the making of the NC programs. And after the making of the NC program, the actual production starts. It is inspected assembly takes and the product is manufactured, inspected, and then the different components are assembled and the final product is realized, and after packing it is sent to the shipping and marketing for shipping and consequently to the marketing. So, to support the design process, we also have certain CAM tools corresponding to the different manufacturing phases. For the first phase of manufacturing, which is called process planning, we have different types of CAP techniques. CAP is the full form of computer aided process planning, and we need to do cost analysis, material and tooling specifications, etc. Another in the next phase, that is the part programming phase, we have tools like NC programming using different types of specially designed languages. For example, one of such languages APT language. Then the next stage is inspection. Here also we make use of the computers, we call computer assisted quality control, and inspection softwares are used for certain types of products. Then we have use of computers in assembly. There are robots which are programmed using, which are flexible to program using computers. Then we have simulation and programming techniques. Now, we are going to understand the definition of CAD tools based on their constituents. So, as we said, there could be CAD tools which are related to the computer graphics concepts. There are certain tools which are related to the geometrical modeling concepts, and there are certain tools which are related to the design tools. So, a CAD tool is one which falls on the common area of these three constituents, and therefore, a CAD tool should have a capability to design, make a geometrical model, and and it should have facilities for the computer graphics concepts. Definition of CAD tools based on their implementation in a design environment. So, CAD tools are a combination of design tools and computers. So, design tools and computers can further be classified into hardware and software. The hardware for CAD tools includes the control unit or CPU, display terminals which are of different types. Previously we used to use CRT terminals, and presently more thinner and bigger terminals such as plasma displays, LCD displays, etc. are in fashion, and there are different types of input and output devices. Input devices are like mouse, keyboard, tracker ball or joystick, etc. and output devices are like plotters, printers, even the display unit is sometimes considered as the output device, because it gives us the instant output of whatever work is being conducted on the computers. Second part of the CAD tools are its softwares which are required for doing graphics modeling application and for running application programs on it. Now, we are going to see the definition of CAM tools based on their constituents. So, these constituents are networking concepts, CAD concepts, and the manufacturing tools, and the overlapping area of these three is being shown in this diagram as the CAM tools. What does it mean? It means CAM tools can provide the facilities for the networking concepts, for the related to the manufacturing tools and CAD. And definition of CAM tools based on their implementation in a manufacturing environment. So, we can see in this diagram that CAM tools are the combination of manufacturing tools and computers, which is consisted of three levels. At the first level, we have hardware, which consists of control unit, display unit, and input output devices, and these things are similar to what we discussed in the case of CAD tools. Then we have we need certain softwares to realize this function, such as CAD softwares, NC part programming softwares, MRP material requirement planning softwares, CAPP computer aided process planning softwares, etc. And third level is the need of networking. So, by combining definitions of CAD as shown here and the definition of CAM as shown in this diagram, we can make a common definition of the CAD CAM tools based on their constituents. So, we can see that the different constituents of CAD CAM are overlapping to be the CAD CAM tools. So, definition of CAD CAM tools based on their implementation in an engineering environment. So, in the following diagram it has been shown that CAD CAM tools are the combination of their design and manufacturing tools and the computers, which has constituents at 3 levels. First are the hardware, and second is the software, and third is the networking. So, this definition has been derived from the last 2 definitions. So, in this particular diagram, if you are going to understand more about CAD CAM, here we are showing a typical utilization of CAD CAM system in an industrial environment. So, we can see that, just follow the pointer, we can follow the pointer on this area, we can see this area is depicting geometrical modeling and graphics package. So, in the CAD CAM system, the first thing is carried out by the geometrical modeling and graphics package. Geometrical modeling of conceptual design is developed, and then decision is taken, is design evaluation possible with the available standard softwares. If it is possible, then design testing and evaluation is conducted. If it is not possible, in that case you can see this area, in this area we have shown programming package. So, we must have facilities, hardware and software for development of the customized programs and packages, and then according to our requirement for the testing and evaluation, we can develop our own programs that can be used with the product that we are going to design. So, once the design evaluation is possible with available standard software or the software which we have developed, the design testing and evaluation is conducted. And then after the conduct of the design and testing and evaluation, it is checked whether the final design is applicable or not. If it is applicable, then it is documented and drafted, but if it is not, then on the basis of the deficiencies or the problems that we have found during the testing and evaluation stage, it is redesigned by the geometrical modeling of the conceptual design. This process is repeated until we get an optimal design, and ultimately when we get a acceptable optimal design, we do its drafting and documentation, and which is sent to the manufacturer. Now, we can see that whatever is shown on the left of this line, I am moving my pointer on a particular line, just see here, whatever is shown in the on the left of this line in the violet color, this is the functions of the CAD, whereas whatever has been shown on the right of this line are the functions of the CAM. So, after the completion of all the CAD processes, we move on to the CAM processes, and we can notice here that we require geometrical modeling and graphics package, and the design package is part of the geometrical model and the graphics package. It can be part of it or it can be independent of it. So, either we would be using a CAD software which provides us both the facilities, that is the facilities for geometric modeling and graphics, and the facilities for the design, testing and evaluation, as well as drafting and documentation, or we may have different softwares for depending upon the requirement. And this is also possible that the standard software which are available with us are not sufficient, are not good enough for the conduct of testing and evaluation for the product being designed by us. In such a case, we develop customized programs and packages which can be used. Anyway, once the final design has been documented and drafted, it is sent to the for the CAM for CAM processing, for the CAM section. So, first of all, as we have seen earlier also, process planning is done. For process planning, we use different CAM packages which are of two types, generative types or retrieval types. So, discussing those is out of scope of this particular lecture. So, once a CAM package do the process planning for the product, we have to check are there manufacturing discrepancies in CAD database. In case there are manufacturing discrepancies in the CAD database, the design is again sent back for reconsideration with the proper feedback, and it has to go through the whole CAD process which it has already undergone. And if it is acceptable, if it is if does not fail if at this stage, then NC programming is prepared for each of the NC machine on which different processes as distributed by the process planner for them are carried out. For NC programming, we have different types of languages I mentioned earlier also, depending upon the machines. For example, one of the popular language is APT language, which is available in most of the standard textbooks on CAD CAM. So, through such a language, we prepared a NC part program which is fed to the machine, and then machine is controlled by such a program and manufacturing is carried out. Once the product is manufactured, it is inspected. Inspection can be of two types. Again, discussing more on the topic of inspection is beyond the scope of this particular lecture, but still it would be pertinent to mention here that inspection could be online inspection, or it could be a sampling inspection. So, if it is a online inspection, then it becomes the part of the machining, and it is conducted on each and every part, and otherwise it is conducted on some of the parts in a lot, and once that lot is accepted, the different parts manufactured are assembled together and the final product is received. Inspection stage and the assembly stage, we make use of the robots. So, this way in a typical industry, the CAD CAM system is utilized. Automation and CAD CAM, this is another important issue that we need to understand for before going into the depths of this particular subject. So, automation, first we need to understand what is automation. Automation can be defined as the technology which is concerned with the application of complex mechanical, electronic and computer based systems in the operation and control of manufacturing systems. So, what automation do exactly? So, if we compare a manual machine and a automated machine, we will notice that the major difference in these two machines is not in how they do their major job, that is machining. The difference is how they are controlled. In the case of manual machines, the control over the various parameters of the machine is achieved or is done by the operator of the machine, whereas in the case of a automated machine, the control is carried out by the instructions by the numerical instructions only. So, this is the major difference. Therefore, what we are doing is, by making a machine automatic, we are making it free from the human interventions. It will work on its own, that may leading to more accuracy, and higher quality of the product. So, once again I am reading the definition. So, automation can be defined as the technology concerned with the application of complex mechanical, electronic and computer based systems in the operation and control of manufacturing systems. So, there are there are four types of basic manufacturing systems.